Hi everybody! So in this next video we are going to be looking at accumulation functions. And once again we're going to start by sort of defining our vocabulary for what an accumulation function is. An accumulation function is any function that is defined as the integral of a different function. So for example, we might say that g of x, our accumulation function, is defined as the integral from some number, whatever we decide to start with, to x of a different function, which in this case I'm going to call f of t and then dt. Now in this problem, g of x is the accumulation function. Because to figure out what's happening with g of x, I'm going to need to integrate a different function, f. So let's look at the types of problems and questions that we can be asked about accumulation functions. So let's let f be a function defined between 0 and 7. The graph of f, consisting of 4 line segments, is shown here. Let's also let g be the function given by g of x equals the integral from 2 to x of f of t dt. Now the first key idea here is to know what you're looking at. We are looking at the graph of f, which is the function inside of this integral. Now we're going to be asked questions about g. So for example, I might be asked to figure out g of 3. Now to figure out g of 3, what that really means is what happens to this function when the x value is 3. So what I would do is I would fill that into my function's formula. So g of 3 would mean to integrate from 2 to 3 of f of t dt. So in other words, to calculate g of 3, I'm going to need to find an area of the graph that I'm looking at, because an integral means I need to find an area. So to do that, I would figure out what area exactly I'm looking at. The integral from 2 to 3 would be this area here in my picture. Now the shape of that area is a trapezoid, so I would find that area by doing 1/2 times the height, which in this case the height would be the distance from 2 to 3, which is 1, times base 1, which in this case is 4, plus base 2, which in this case is 2. When I figure that out, so 4 plus 2 is 6, times 1 is 6, divided by 2 is 3, I would get that g of 3 would be 3. Next, in part B, it says find g prime of 3. Now there are really two components to this question. I need to first figure out g prime before I can plug in the number 3. So let's work on that part first. To find g prime of x, I am going to need to take the derivative of this integral. Now, one of the things we learned was that the fundamental theorem says if you take the derivative of an integral, you end up just plugging in the x to the integral and then multiplying by the chain of the bound. In this case, that would mean that my new function is just f of x. And since the derivative of x is 1, there would be no chain to multiply by. So now that I know that g prime of x is just f of x, if I want to find g prime of 3, what that really means is that I need to find f of 3. Now if I think about what this means, finding the integral meant finding the area, but finding f of 3 just means find the y value. So if I look at this graph, when x is 3, the y value is 2. So my answer would just be 2. I should probably put a box around that so we can read our work more neatly. For finding g double prime of 3, First, we're going to need to actually find the second derivative. Then we can plug in the number 3. So to find the second derivative, I'm just going to take the derivative of what I just had. Since g prime of x was f of x, g double prime would be f prime of x. I'm just taking the derivative of what was just there, which means to find g double prime of 3, I would just plug the number 3 into my f prime function. And then we need to think about what that means. Since f prime is the derivative, this would mean finding a slope. So if I look at the slope of the line that goes through this point where x is 3, since this is a straight line, the slope can be found by just doing rise over run. The rise here would be down 4, the run would be 2. So my answer would be negative 4 over 2, which is just negative 2. For part D, it says, find the critical points of g of x. Then identify where g of x is increasing and where it is decreasing, and justify your answers. The first thing we're going to need to do here is remember what a critical point is. A critical point is a place where g prime of x, the derivative, is equal to 0 or is undefined. So let's start with that. First, to find the critical points, I need to figure out where g prime of x is equal to 0 or undefined, which means I'm going to need to know what g prime of x was. Now, lucky for us, we found g prime of x up here. So if I review from part B, we figured out that g prime of x was just f of x. And what we need to know is where does that equal 0 or where is it undefined? To figure out where f of x equals 0, what we're really just looking for are the x-intercepts. So if I look at this original graph, the x-intercepts are at 0, 4, and 6. Now, I could also look for where f of x was undefined. In other words, are there any places where f of x doesn't exist? There's holes or jumps. If there's maybe asymptotes or something where the domain is undefined. In this case, since everything is connected, f of x is defined everywhere. Now, you might be thinking to yourself, what about those corners? Doesn't that mean something? Because those corners are there, f prime of x, or the derivative, would not exist on this graph, but that doesn't mean that the function is undefined. So I've gone ahead and I've found my critical points. Now the second part of this question is asking for where g of x is increasing. G of x is increasing means g prime is greater than 0. It just means the slope is positive. So again, I'm going to need to know what g prime is. Lucky for us, we still know from part B that g prime of x is just f of x. And we are going to want to know where that is greater than 0. Now, greater than 0 means above the x-axis. In other words, it has positive y values. If I look at this graph, I'm above the x-axis from 0 to 4 and from 6 to 7. And when we learned about increasing and decreasing, we said we always use closed brackets for those. So that would be my answer. Finally, I want to know where g of x is decreasing. So in other words, the derivative is less than 0. So we're going to figure out where the derivative is, where g of x is decreasing, using that same function we found in part B, which is that the derivative is just f of x, and figuring out where it is less than 0. Now, less than 0 is going to mean below the x-axis. In other words, we have negative y values. So if I want to figure out where I'm below the x-axis, I'm just going to look at this graph, which is between 4 and 6. The last part of the question says, make sure you justify your answers. So to justify our answers, we just have to say why this works. So you would say these are the critical points because g prime of x, which is equal to f of x, is equal to 0. For increasing, you would say because g prime of x, which is equal to f of x, is greater than 0. And for decreasing, you would say because g prime of x, which is equal to f of x, is less than 0. You always want to show in your reasoning, how you're relating g and f. Because we can't just say f of x is above or anything like that, because we're trying to talk about g, and what we have is f. So we have to show that relationship in our reasoning. A few more questions that you might get asked. So we're working with the same exact setup. I just reprinted it on the other page so you didn't have to keep flipping back and forth. Same exact setup. Part E says find the x coordinates of the points of inflection and then figure out where g of x is concave up and concave down and justify your answers. Now, just like we started by figuring out what the heck a critical point was, we're going to try to figure out what a point of inflection is. So we need to review. A point of inflection was a place where the second derivative was equal to 0 or undefined. So instead of looking at the first derivative now, we're going to need to look at the second derivative. So let's start with that. Now, one of the things that made a point of inflection a little bit different was that the second derivative has to change signs. For a critical point, you don't necessarily have to have your derivative change signs there, but for a second derivative, you have to actually change signs in order to qualify. So if we go back to part C, what we figured out was that the second derivative of g was the first derivative of f. Now, if we want to know where we are equal to 0 or undefined, what we're going to do is look for where the slope doesn't exist. In other words, corners, cusps, vertical tangents, and discontinuities. So in this graph, the slope doesn't exist at 2, 4, and 5. Then we also need to look for which of these actually change signs. So at 2, the slope changes direction from uphill to downhill. At 4, the slope does not change direction. It's going downhill on the left and downhill on the right. And at 5, the slope does also change direction. So we would narrow down this list to just 2 and 5. For part 2, we want to figure out where our graph is concave up. So to review, concave up means that the second derivative is greater than 0. Now again, from part C, we knew that the second derivative is really just f prime. So we want to figure out where that is greater than 0, or in other words, where the slope is positive. So my slope on this graph is going uphill from 0 to 2, and again from 5 to 7. So we would say 0, 2, and then 5 to 7. Now you'll remember when we learned this the first time, we said that concavity is always going to have open parentheses. So we're going to make those open intervals. Last but not least, concave down. Now concave down means that the second derivative is negative. So we are going to look for, again from part C, where is g double prime, which is just f prime, less than 0. In other words, where is our slope negative? Well, in this graph, the slope is negative from 2 to 4, and then the slope doesn't exist at 4, and then 4 to 5. So we would say 2 to 4, and then 4 to 5. And the reason we have to separate that interval is because this is an undefined value for the slope. Remember, we took it off of here because it was a corner. So now to justify our answers, we would say here, because g double prime of x, which is f prime, is greater than 0, and here we would say because g double prime of x, which is f prime, is less than 0. For part F, it says identify the x coordinates of the absolute maximum and absolute minimum of g of x. Justify your answers. So, we need to remember what absolute maximum and absolute minimum mean. The absolute maximum and absolute minimum are always going to occur when the derivative equals 0 or at the endpoints. I guess I should also say here, or does not exist. So it has to be a critical point or an endpoint to make a max or a min. Well, if we think about the derivative, so step 1 is to identify the critical points. The derivative of g was just f, which we learned from part B. If I want to know where that is equal to 0 or does not exist, we already did this in part D, and we said that's going to happen at 0, 4, and 6. Then I'm going to make an options chart. My x's are going to be my options, and my y values are going to be the actual how high or how low does it go. Now in my options chart, my endpoints are going to be there. So 0 is my first endpoint. My last endpoint is going to be 7, and I'm going to put any critical points in between. So in between here, I'm going to list the 4 and the 6. To figure out the absolute maximum and absolute minimum, I need to know how high, or in other words, the y value of g, we actually go. So to figure out g of 0, I'm going to integrate from 2 to 0 my f of t function. Now on the graph, the integral from 2 to 0 would be this triangle. But what you'll also notice is that I'm going backwards. The bounds are in the wrong order. So even though this would normally count as a positive area, since it's above the x-axis, in this particular problem, it's going to count as a negative. So I'm going to have negative, and then 1/2 times the base, which is 2, times the height, which is 4, which is just going to be -4. Next, I need to find g of 4, which is the integral from 2 to 4, f of t dt. Now, if you look at the graph, the integral from 2 to 4 is the same size as the integral we just did, except in the positive direction. So it would just be positive 4. To figure out what happens at 6, g of 6 would be the integral from 2 to 6 of f of t dt. Now to go from 2 to 6, I'm just going to take what happened at 4 and subtract this little triangle. So I'm going to have 4, which I already had, minus 1/2 times the base is 2 times the height is 1. Now half of 2 would just be 1, so 4 minus 1 would be 3. And to figure out what happens at 7, I would want the integral from 2 to 7 of f of t dt, which means take what you just got, the 3, and add in that little triangle. So plus 1/2 times the base times the height, which would be 3.5. Now based on that information, for step 3 here, what I would say is that the absolute maximum occurs at x equals 4, because this is my highest y value. And the value, the maximum value, is 4. Then I would also say that the absolute minimum occurs at x equals 0, because that was my lowest value since it's negative, and the minimum value is -4. Now, as far as justifying your answer, showing your options chart that you considered the critical, oh, you can't see what I just wrote, I'm so sorry. Showing your options chart and showing that you considered the critical points as well as the endpoints counts as justifying your answer for these questions. For part G, it says find the average rate of change on this interval. So we need to again remember, what does average rate of change means? Average rate of change just means regular old slope. So in other words, to find this, we would just do g of 3 minus g of 0 all over 3 minus 0, where 0 and 3 are my endpoints for my interval. Now, if you think back to what we already did, we already calculated g of 3 in part A. So I'm just going to use that result, which was 3. Minus, we also already calculated g of 0 in part F. So minus -4 all over 3, which simplifies to 7/3. And lastly, for how many values of c is the derivative equal to the average rate that we found? Explain your reasoning. So in other words, we want to know if g prime of some number is ever equal to 7/3. Now, if we think back to what g prime was, we learned in part B that g prime of x was really just f of x. So g prime of c is really just f of c. And we want to know if we ever equal 7/3. 7/3 is 2 1/3. So is the y value ever 2 1/3? Well, if we look back up here at the graph, 2 1/3 would be a horizontal line like right there, which means I'm going to achieve that y value twice. So I would say g prime of c will equal 7/3 twice on the interval 0 is less than c is less than 3 because g prime of c equals f of c equals 7/3 twice. All right, that's it. Thank you guys so much for watching. We will definitely be spending a little bit of time practicing these things, and I will see you in class.